Hello, this is James from Flagtronics. Today we're going to cover CAN integration with the FT200 and other Flagtronics hardware. We're going to start off on our website here. It's the simplest place to go. So from our website, we're going to go to the CAN bus documentation button here. And that's going to take us to our GitHub repo here. And we have an edit just a few minutes ago, so we're going to download that. So we're going to go to the relevant folder here. Just downloaded, and then we will extract it, and we'll end up with the folder here. Now this is version 0.4. The DBC file is going to be updated later today, so we'll get to that, but we're going to start off with how the basic structure works. So we have a bus structure that can operate at different bus rates, different baud rates from 125 to 1 meg, 125K to 1 meg. By default, it's set at 500K, 11-bit, little endian, and it's expecting a blank message or any message on 04 dB, and it will respond, so that's 4 dB, on 4 DC. There's another way to set this to automatically send instead of response request. We prefer response request so that we don't pummel a bus with messages that are unwanted. But we do offer the ability to set it to auto send or to do the standard response request. So we've got a few bytes here, 2 bytes for our first message, which is displayed state. Displayed state shows what's actually on the screen. So it sorts out any hierarchy between the full track, local, individual, and accident flags as an example. So it will show you the actual display that the driver sees. And we repeat that from bytes 0 to 1, again on bytes 0 to 2. So sometimes we get the question, hey, Flagtronics guy, why did you repeat it on the second set of bytes there? And the answer is that the first 2 bytes we use with the 16-bit message here for codes, for video, for standard logging, and the second 16-bit message we use for encoding to be able to put the word red instead of a number, decimal or hex number on the screen, for example. It helps with some logging systems, so we repeat it. Then we get into the 8-bit IDs. So full track state will tell you if it's full track yellow, green, red, checkered, etc. Local flag state, this can be a local waving yellow, local standing yellow, debris, etc. The individual state, this could be a meatball, black flag, courtesy pit. Accident bit flag, this will just say if you have an accident or not. Accident Gs, this will represent how many Gs the accident was. So it caps out at 127, and it will just say 127 plus at that point. And then we also have another message which is not active at this time, but will be representing speed and some debug or informational states, like some battery information. And we also have some lap time and pit time information. So we'll get into those in some of the settings here. Let's cover the default settings that the software has. By default, it's set to a 500K baud rate, but this is programmable. The ID that we send on is 4DC, and the ID we receive on to get the request to send out on 4DC is on 4dB. These are in hex, but you can change it to decimal. There's big endian if you choose to use that. Extended also if you choose to use that. By default, we don't have them on. For send is auto send, and if you click that, you can choose a different rate from 2 to 5 hertz is our general recommendation. And we do have newer software coming up, and the settings will look just a little bit different here. So we'll have the different rates here. The addresses are programmable. You can change them if you want to. So we can change it to big Indian. If we want to use extended frame, it automatically changes the address system here. And then to auto send, default is 2 hertz. Some people will want 5 hertz depending on the series and what you choose. We also have the codes here, and just to cover briefly how that works, we chose an offset. So these are full track here. These are locals here. That's the 4096 offset for the displayed state. These are individual, and these are debug. So as an example here, a green flag is going to show up as decimal 71 or hex 47 on the displayed state. If we had a local checkered, as an example, that would show up as decimal 26 plus the offset 4096 under displayed state for the 16-bit displayed state. But under the individual 8-bit message, it will only show up as 26 or 1A, depending on your hex or decimal setting. And the same goes for the other messages. So we'll see a converted chart that's a little easier to read, and the DBC file is also easier for most people to implement who don't want to sort of trudge through this part of it. All right, and we do have a demo mode. We do offer that. So we have a few examples here. I'm going to cover one example. We'll say full track green. So the full track message is going to say 71. The 16-bit displayed state message will say 71. And so we'll have 4700 as the first displayed state byte or bytes. And 4700 is the second display state bytes. And then the full track state byte will be 47, and then the rest in this demo mode anyway are 000. So let's cover another scenario. Let's do a local. So let's say waving yellow. So waving yellow is 2 for the individual byte. So we'll see the O2 represented here. And now we have the offset 4096 plus the 2 value. So now you can see a little bit why we chose that 4096 offset. It works out pretty cleanly because the code comes through as 2 plus the offset 10. So 0210, 0210 for the 2 displayed state bytes, and then the full track byte is 0. The local is 2, and 0 for individual, and nothing for the accident trigger there. So it makes it easy to read this way with these particular offset methods. All right, so now we're going to go to individual black flag if your car is being black flagged. So that's 1 on the individual message. And so we can see displayed state is going to have this offset, so we know it's an individual message, and it is 1 for black flag. And then it shows up, there's nothing for the full track state here, nothing for the local state, and then we have the individual state filled out here. Let's do one of the examples for an emergency flag. And each one of these has the value represented here. So this is 75 is the emergency flag, and we represent that as 4B20 here and here. And then the last one is to show, the last byte here shows that there is an accident. So the accident would be 80, and then we add 10, which is the 0A. So 8A means that we do have an accident, and it's 10 Gs. The rest of these represent the same thing, where 99 means that we do have an accident, it's 25 Gs. B2 means have an accident, it's 50 Gs. CB, accident, 75 Gs. E4 is we have an accident, that's 100 Gs. We have some other individual commands in here. These are the informational commands which show up in another message. But if they are displaying on the screen, you will still get the output of the screen display. So you will still see in the displayed state what these are. All right, so that covers sort of the structure. If you know what a DBC file is and how to use it, obviously you can load that up and it's going to give you the same message structure. Some people are going to find that easier to use. Let's go into the software here for a moment. And this is the newer software, but right now, and I'm going to bring up the pecan, which must have closed. All right, and right now I am sending a message out. So I'm just sitting blank on 4dB, and I'm sending that at 5 hertz right now, or 200 milliseconds, and I'm getting the response right now, which actually says SIG on my display because I don't have any equipment on. in the office here. So we're going to show the demo mode method, and I'm going to say select it from the local machine. I have this pre-selected. We're going to make some more automation, but for the moment, this is in your C drive, program data, Flagtronics, device manager, Flagtronics device manager, firmware, FT200, main, and demo mode. So we do have a demo mode in the latest software. We can load that up and we can start the firmware update process. And this is going to give us the actual codes. So you can validate your actual display, your logging system, your telemetry system live, and you can make sure all of your integrations are fully functional and working. I'm going to choose to display this on the pecan. All right, so also we prefix this. So any demo mode is going to start with 13 for D, just the conversion from decimal to hex. So you're going to know you're in demo mode by the prefix 13 here. So we got that. I'm going to close those out. And we're going to bring up our flag codes here, put them on one monitor and the pecan on the other monitor. All right, so right now we've got nothing, and I'm going to press the up arrow button, which is how demo mode works. You press up or down arrow, which you can't see, but that's how it's set up. So right now it's on blank, so we expect 42 for the displayed state, and then 42 for the full track. So that's working. And we can go through, this is the PIT message here, or I'm sorry, not PIT, the code 35 purple message. And I'll hit the up arrow again. This is full track black flag. This is full track green. This is checkered flag. And again, this is following the sort of expectation here on the CAN output. This is the PIT, red, full course yellow. This is an invalid state here, which, I'm sorry, this is white still. Let me hit it one more time. This is the invalid state here. And this is if there's a command that you don't have, which could happen if your firmware is out of date. Usually we try to do a yearly update, and we tell everybody to do that once a year update. All right, so this is a none flag, which is a local state, so it has the local offsets. And then we have the local yellow, and this is a waving yellow. So we have the displayed state bytes, and then full track is 0, and the local is yellow. I'm going to continue through these pretty quickly at this point. We're still in the locals here. And I want to get over to the individuals. Okay, so this is an individual. Now we've got the next offset, so we know we're at 8192. And this is a individual black flag. So we've got black flag on the individual byte, nothing on the full track, nothing on the local. And I'm going to get us to an emergency flag. So we have the emergency status here, which is 4B20. And then we have the 10G hit here. So you can press up or down to go through all these and validate every single message we have in this list. This is a low battery message right now. So right now we're on the informational byte, and it tells you that it's got the offset to the 12,288 plus 1. All right, now we're going to cover a little bit in Race Studio. We have some examples for this, so I'll put some templates for certain systems. When it's response to request, we have this message going out, and we get to choose what the rate is. This is actually set to 1 Hertz, but you could set it to 2 or 5 or the recommendations, other recommendations. And it doesn't matter what value is here, you're just sending out a blank byte. So now we continue on to the alarms, which is the primary place where we set these up. So here we're going to set up a red flag that's going to come in and say it's equal to 82. which is a red flag, and we could choose the actions that we're performing here. And this is on the basis of the CAN data stream that we have coming in. So this shows the different bytes and what's going on. So this is based on the translation from this table, and this is the displayed state. So this is where we're able to set up any special encoding or enumerations with this. We're just using the raw values for the display in this example currently, and it has the full track, local, individual, oxygen G data. All right, so that's an AIM quick example. We're going to have some MoTeC examples soon. We have a nice ECU Master ADU. You were kind enough to work with us at the PRI show and get that going. So we can see the yellow bounces between these two. Checkered flag blinks between these two. We have code 35, black flag, green, and generally we'll have this in a lot of different logging systems. But that generally covers what we need for the CAN integration system. Once you're done with demo mode, you can take this back and say, I want the latest release and I want to update the main firmware. All right, and now we're back to the normal firmware, which will show up when we go through here. So we went from demo mode back to the standard mode successfully. Looks like that all worked. So everything is set up, and you could change your settings here if you want to.